pH can be an important factor in all living things. So today we're doing a lab to determine pH of a variety of household products that you might encounter in your daily life. The objective of the lab is to determine the pH of various household chemicals. So we're going to use ammonia, pine sol, lemon juice, milk, orange juice, oven cleaner, Sprite, vinegar, and water. And we're going to test each of these substances with a substance that is called an acid-base indicator. We used a cabbage solution. We soaked hot water in some cut up purple cabbage, and we put about 10 milliliters in each of the test tubes, and we marked the test tubes A, B, C, D, E, and F, and G, and H, and I. We recorded each of those solutions in our data table: ammonia, floor cleaner, lemon juice, milk, orange juice, oven cleaner, Sprite, vinegar, and water. After we added a couple of drops of each of these solutions into the test tubes, they changed colors. The test tubes changed colors, which also told us what the pH was. Here's a picture of the results after the solutions were added to the cabbage solution. So A is obviously a bright green color, B is sort of a turquoise color, C is bright pink, D is sort of a lavender purple, E is another pink, but it's maybe a little bit more purple, F is another shade of green, maybe a little bit more blue but green, G is violet colored, H is pink again, but maybe not quite as intense a pink as that one, and then I is purple, is violet. And we wrote those colors right in here. The approximate colors and their pHs, the approximate pH and color is in this data table. The red in our data turned pink, and so some of the pinker ones are going to be in the 1 range. And down in here, if it's between violet and blue, it's going to be in the 7 range. Here's the data once again. Once you're finished determining the color and the pH, then you need to start working on your graph. And it's no surprise that the graph is about the same size as the data table. So you can label down below A, B, C, D, E, F, G, H, I, and you can have the approximate size of each of the data tables. You're going to create a bar graph, and each bar will go up. So for example, if A was a green color, green was running between 11 and 12. So you would create a bar graph that would go up from the A to the 11, and you would color it in a green color. And then you would color in all the rest of these based on the color that you observed in your data table. And again, you can look at the picture just to determine the proper coloring. Once you're finished with the graph, then you can start on the pH scale. And remember, a pH scale is like a number line. It starts at 0, goes to 7, goes to 14. And you would make these segments even numbers of segments. So your scale is going to be a 0 to 14. And then what you're going to do is you're going to put all the low pH numbers in here, and you're going to write the word. So lemon juice is going to be right about here, and you can write both on top and on the bottom of the line. So lemon juice and orange juice, and maybe the soda is going to be about here. And so you're just going to write those words somewhere on this line so that you can see quickly what the products are and what their scale is going to be. When you're done with the scale, then you need to analyze and answer these questions. It helps to have read the background information at the beginning of the lab. Don't forget, we're going to do the conclusion together in class on Thursday.